Welcome back. This is Mr. Hassan's Maths channel, and I'm now going to go through question number 4 from the January 2024 Pure Mathematics P3 paper from Edexcel International A-Level. Here we have a function defined by f of x is equal to 2x squared minus 32 over 3x squared plus 7x minus 20 plus 8 over 3x minus 5. And it says x is an element of the real numbers and x is greater than 2. Show that f of x equals 2x over 3x minus 5. Okay, so here we're given a domain which will most probably come in useful in the question somewhere. So don't keep that in mind. Don't forget about that. Show that f of x equals 2x over 3x minus 5. So what they've done here basically is they have added these two fractions together and combined them into one, and things must have simplified. So what we can do here is we can try to find the LCM of the denominators. In order to do that, we should factorize this expression. Now, in these kind of questions, you can take a few shortcuts that will help you. And I don't mean, cheat type of factorizing by using your calculator, but using some guesstimation. Now, if you're going to end up with 3x minus 5, it's possible, it's highly likely that one of the factors of this is going to be 3x minus 5. It's highly likely that that's what's happened here. So instead of going through the whole process of splitting the middle term or whatever and trying to factorize, you could assume that one of the factors is 3x minus 5 and then see, actually, does it work? So what would have to be put here for this to be 3x minus 5, and you multiply by something to give you 3x squared plus 7x minus 20. Well, 3x times x will give you 3x squared. And let's look at the constant at the end. You have minus 5 times plus 4, which will give you minus 20. Now we check, does it work? Will this actually expand to give us this? If it does, we've got the answer. So you have 3x squared plus 12x minus 5x, which is plus 7x minus 20. So it worked, okay? We used a bit of guesstimation there to make life easy, which is what I like to try and do. So now we have 2x squared minus 32. Let's also try to factorize this. We can start off by taking out 2 as a common factor, and we have x squared minus 16. And you should recognize that there's something else we can do with this. These questions where it says show that, you have to show your steps very clearly. So don't just, write everything down at once. Now I'm going to now split this up into a difference of squares. When you factorize a difference of squares, you have x squared is a perfect square. You have 16 is a perfect square. There's a minus sign between these two terms. So you write the square root of each of those terms in the brackets. And one of them is going to be positive. The other one's going to be negative between them. So x plus 4 times x minus 4 gives us this. And that makes everything nice and neat for us. Because before we start actually doing any addition of these two fractions, we can simplify that fraction first. And you'll notice the x plus 4 and the x plus 4 cancel out. So you're left with 2 times x minus 4 over 3x minus 5 equals, plus 8 over 3x minus 5. Now we have a fraction with a common denominator. So we can write it under that common denominator, 3x minus 5, and just add the numerator. So you're going to have 2x minus 4 plus 8. So that's going to be 2x minus 8 plus 8. They cancel out. So you're left with 2x over 3x minus 5. And that's exactly what we had to show. So we can say that f of x is equal to 2x over 3x minus 5. Okay, simple as that. So save yourself a bit of time. Use a bit of common sense. Think, okay, if you end up with this 3x minus 5 at the end, that one of these factors most likely will be 3x minus 5, and it works out to be correct. All right, so that's part A done. Now for part B, it says show using calculus. Using calculus that f is a decreasing function. And we have to also remember what we wrote here. X is an element of the real numbers. X is an element of the real numbers. And x is greater than 2. That will help us here in this question. So we want to show that f is a decreasing function. A decreasing function is a function that is always got a positive gradient. Now, we could do this by sketching if we wanted to, but we can't. in this particular case because it says show using calculus. That means you got to show using the gradient function. You've got to show using differentiation. So we got to take this expression and we got to find what f dash of x is, the differential of it. Okay, so f dash of x, here we have a quotient of two separate fractions. So we're going to use what's called the quotient rule. So the numerator is called u, which is 2x. The denominator is called v, which is 3x minus 5. We're going to differentiate u, that gives us 2. We'll differentiate v, that gives us 3. And the quotient rule, you always start on this top right, v. You start with v. So you cross multiply. So you multiply these two together. So 3x minus 5 times 2. So 2 times 3x minus 5. Then minus, always minus, these two multiplied, which is 3 times 2x. And then you always divide by the differential of, you always divide by the square of v. The square of v, so it's going to be 3x minus 5 all squared. Okay, so all of that is what f of x is equal to. F dash of x is equal to. This is the differential. Okay, so let's just simplify this first, and then let's try and figure out how we can prove that it's always going to be decreasing. Decreasing means the gradient is going down. The gradient is always negative. I don't know what I said earlier. Maybe I said something else. But decreasing means the gradient is always going to be negative. This gives you 6x minus, that's a 5, so it's going to be minus 10 minus 6x over 3x minus 5 squared. 6x minus 6x becomes 0. So we're left with f dash of x is equal to negative 10. Negative 10 over 3x minus 5 squared. So now we got to prove that this expression is always going to be negative. Okay, now we know that the numerator of this fraction, the numerator, which is negative 10, okay, is always negative, of course, because it's constant. Always negative. Okay, let me write it properly, negative. And we can say that the denominator, which is 3x minus 5 squared, okay, as x is greater than 2, therefore this is always going to be positive. Always positive. Okay, so the denominator will always be positive because we know one of the conditions is x is greater than 2, right? So, you know, even if this could become, this could have become 0, in which case that's going to be undefined. But it can't become 0. Why? Because x is always greater than 2. Okay, and then you're going to end up, you know, with something which is always going to be positive. You're going to square it. Even x could be less than 2, for example. Even if x could be, for example, minus something, this is always going to be positive. Why? Because it's going to be squared. As long as it becomes 0, the whole thing becomes undefined. But in our case, it can't become 0 because we know that x is greater than 2, right? We're only considering those values. So this is always positive. So therefore, we can say we'll have you can say f dash of x, the gradient, is going to be negative over positive, which is negative, right? So we can say that as, we should be very careful to state our reasoning, as the gradient of f dash of x is less than 0 for all values in the domain of our function, in the domain, okay, therefore we can say that it is a decreasing function. It is a decreasing function. Decreasing function means the gradient is always negative for every value of x that x can take. In our case, you know, it's going to be, for x is greater than 2, this is always going to be a decreasing function because it'll have positive divided by negative. Right, so that's good enough reasoning here to answer this question, part B. Or question part C. Here we're told that a function g, so it's a different function now, is defined by g of x equals 3 plus 2 ln x, where x is greater than or equal to 1. Find the inverse of g of x. Okay, so we're going to find the inverse function. Now, when we're asked to find the inverse function, we should always keep in mind that we need to also state the domain of the inverse function as well. Okay, so always keep that in mind. A lot of people think, you know, they find the inverse function and they they see they lose a mark from the mark scheme because why? They did not state the domain of the inverse function. It must always be stated whether the question says, state the domain or not. Okay? Whether it says it or not, you should always state the domain of the inverse function, unless it says find an expression for the inverse function, which is quite common in, say, Cambridge questions. It says find an expression for the inverse function. In that case, you only find the algebraic expression. You don't need to write down the domain. But if it says find the inverse function, that implies you should also state the domain of the inverse function. Okay, so that's important. So first of all, the algebraic expression of the inverse function. First step, let's call the function y. So y equals 3 plus 2 times the ln of x. And second step is what I like to do at this stage is to replace the x with y and the y with x. And the next step is to make now y the subject of this formula. So we're going to take the y and make it the subject. So first thing I'll do is I'll subtract 3 from both sides. And then I'll divide by 2. Okay, now remember, log to the base a of b equals c can be written in index form as a to the power of c equals b. And if you remember that the log to the base e is the same as ln. The log to the base e of something is the same as ln of that. That's what it means. Ln means log to the base e. So basically, if we want to rewrite this in index form, we can say that e to the power of x minus 3 over 2 equals y. So we can rewrite this as y equals e to the power of x minus 3 over 2. So this is the inverse function for this log function, right? Now, the range of the original function will be the same as the domain of the inverse function. So let's look at the range of this function. Okay, the range of this function. Okay, the range of this function is going to be as follows. If we were to draw this function, you have 3 plus 2 ln x. So let's start off with what ln x looks like. I'm going to just make a little sketch to make it clear. So we have our axis. Okay, so ln x starts off like this. This is ln x. Okay, goes through 1 here, right? That's what ln x looks like. I'm going to draw it without this first, and then I'm going to include the domain stuff. All right, so the next thing that happens is everything's outside the function, multiplication. So you multiply everything by 2. What effect will that have? Well, it won't change this. It doesn't change any of the x coordinates. It just changes the y coordinates. So it's just going to be basically kind of a bit more stretched vertically. It's going to be a bit more stretched. You can't really show that without other points with it, but it'll be something like that, stretched slightly compared to the original. All right. So then after that, what happens? All the y coordinates, you add 3 to them. So this goes up, and this goes up 3 units. So it's going to go something like this. Okay, but it's going to start, because it's x is greater than 1, it's going to start from here. Okay, so this point here, we could have found it. We could have put when y equals 0, you'll have, ln x equals minus 3 over 2, and you could then work out what it's going to be. But we don't have to worry about that. Why? Because it's going to be only starting from this point where x equals 1. And this is going to become the point 1 and 3. 1 and 3. So this is going to be 3, and this is going to be 1. So we can see that the range of this function, is going to be from 3 upwards. Not including 3. Why? Because it does include 3 because there's an equal sign there. So it's going to be, the range of this function is y is greater than or equal to 3. It's going to continue on forever upwards. So that's the range of the original function, okay, which is going to be the domain of our function here. So the domain of this function is x is greater than or equal to 3. And you can see that, that basically here, if you were to draw this, if you were to draw the inverse function for this, it's going to start, instead of being 1, 3, it's going to be 3, 1. Okay, it's not really very, accurately drawn, but it's going to look something like that. It will be reflection y equals x if you draw accurately. The inverse function will look something like that. And you can see its domain is going to be from 3. This will be 3, 1. It's going to start from 3. So it's going to be, its domain is going to be x is greater than or equal to 3. You can see that if you try to sketch the inverse function. Okay, so that is the domain. It's better to state this as well. If you don't, it's okay. X is an element of real numbers, and x is greater than or equal to 3. So don't forget to state the domain always, even if the question did not require you to do so. Always state the domain. Okay, even if the question didn't explicitly say, okay, state the domain, it means, if it says find the inverse function, it means with the domain also defined. Okay, so always assume that, otherwise you will definitely lose marks in such questions. So there's part C done. Now we're going to go on to part D. It says find the exact value of A for which g of f of A equals 5. So g of f of A equals 5. Now, A has to go into the function f, and fa has to go into the function g. Okay, now if we look at the domain of g, okay, what can go into g is any value of x which is greater than or equal to 1. And what can go into f is any value of x which is greater than 2. All right, so we've got to keep that in mind when we solve this equation. We might end up with some values of a which can't go into f or can't go into g, so that we can't include them in our solutions. That's a possibility that could occur, so you have to watch out for that. So first of all, let's work out what the expression is for g of f of a. So you want to put a into the function f first. So f of a means basically 2a over 3a minus 5. And then g of f of a is you've got to replace the x here with f of a. So g of f of a is going to be 3 plus 2 times the ln of 2a over 3a minus 5. Okay, and then we got to equate this to 5 and solve this equation. So we got to say 3 plus 2 times the ln of 2a over 3a minus 5 is equal to 5. Okay, and now we can subtract 3 from both sides. So 2 times the ln of 2a over 3a minus 5 is equal to 5 minus 3, which is 2. The 2's cancel when you divide, so you're going to have 1. So we have ln of 2a over 3a minus 5 is equal to 1. Now remember, ln means e to the power, ln log to the base e. So we can say here that 2a over 3a minus 5 is equal to e to the power of 1, which is e. Okay, we want to find what a is. So if we rearrange this equation and solve for a, we will get the answer. So we're going to multiply both sides by 3a minus 5. So 2a equals e times 3a minus 5. If we expand this bracket, we get 3 times ea minus 5e. I want to bring the a's together. So what I'll do is I'll add 5e to both sides, and I will have 3ea minus 2a. Subtract 2a from both sides. I'm going to take a as common here. So I have a times 3e minus 2 equals 5e. So therefore, we can say a is equal to 5e over 3e minus 2. So that's the exact value of a for which this is true. Okay, so there is the answer to our question. Okay, now, if you wanted to be, if you know, in this question, I don't think there's anything really more to that. You won't have any issues. But if you were to check to see if a can actually take that value, we could put that value and check that that value is greater than 2. And then when you put that value into the function f, that value is greater than 1. Why? Because any value less than 2 can't go in here. And any value less than 1 can't go in here. Okay? So that's what we could check that if we wanted to. Okay, all right, and you know, why don't we just do that just to make it more complete? Just this is not necessary for you in the question in the exam, but just for your understanding for other questions, it might help you. So 5e over 3e minus 2. That's the value of a. So let's see what that actually gives us when I put it inside this function here. So we have 2 times sorry, 2 times, we have 5e. Now e is found by using this button, divided by 3e, minus 2 in the denominator, divided by 3 times, we're going to have, okay, sorry, I've got that already. What am I doing? 3 times, yes, divided by 3 times, the same thing, 5e over 3e minus 2, okay, and minus 5. That gives us 2.718. Okay, so that we can see that that is basically acceptable to go into the function f. So this can go into function f, that's fine. And then when you put this value into here, okay, to find what, so this can go into function f, that's the value of a. Now when you put, this can go into function g, right? This can go into function g because it's greater than 1. Well, what I should have checked was what's the value of 5e over 3e minus 2 first. Okay, well, we've confirmed that when I put this into there, what comes out can go into function g. Okay, so that's fine. But what I should have really checked first was, can this go into, let me just get rid of some of these things that might help. And this go into function f in the first place, which of course it should be able to because it's the only answer we got. Press this, we see that that's a value which is greater than 2. Okay, so it can go into function, this can go into function f, that's fine. And then what's the output of this can also go into function g. So everything's fine, there's no problem with this answer. This answer for a, okay, the value of a is greater than 2, so it can go into the function f, and it's greater than or equal to 1, so it can go into function g. So it's a perfectly good answer. Now, if you ended up with 2 answers and one of them is such that it doesn't fulfill those 2 conditions, that it can go into f and the output of f can't go into g, then it will not be a solution that we can accept. Okay, so that's something that does come up sometimes that we should be aware of. So there's the end of question number 4. Thank you for watching. Other questions from this particular paper can be found in the playlist that will appear in the top right of the screen at the end of this video. Other questions from the topic of functions, okay, including, ranges and domains and inverse and composite functions, whatever, can be found in the playlist over here. You can subscribe to my channel by clicking on this link, and the video that will be linked at the top tells you how to use my channel to find the index forms, which will help you to navigate the channel in an efficient way. Thank you for watching and see you soon.